So in this class, we shall be discussing about a copper containing oxygen transport protein, that is hemocyanin. ঠিক আছে? It is a copper containing oxygen transport protein. The first copper containing oxygen transport protein found in certain mollusks as well as in arthropods. Found in certain mollusks and arthropods. Okay, so this is a copper containing oxygen transport protein. Now, usually these proteins, they are made up of they are actually made up of several monomeric units, and usually these proteins are polymeric in nature. So these proteins are polymeric polymeric in nature. See, if you just think about hemoglobin, it's a, you know that it's a tetramer of myoglobin. হেমোগ্লোবিনে তোমাদের মনে আছে যে it's a tetramer of myoglobin, চারটে myoglobin like unit. এখানেও কিন্তু এখানে কিন্তু অনেকগুলো ইউনিট থাকে, ঠিক আছে? Now each unit, they contain an active site to carry out the oxygen transport. So they consist of several units. So কিরম units বা subunits may consist of, দেখা যায় অনেক সময় 6, 12, it can be 24 as well as 48 subunits. Now each of these subunits, they contain an active site where copper is present. ঠিক আছে? যেখানে কপার আছে, প্রত্যেকটা ওই মোনোমারিক সাব ইউনিটে অ্যাক্টিভ সাইটে কপার আছে। তাহলে আমরা এবার নেক্সট উই শ্যাল ট্রাই টু আন্ডারস্ট্যান্ড দ্য স্ট্রাকচার অফ স্ট্রাকচার অফ the deoxyform of HMC. That means we need to understand the structure of deoxyform of HMC. That means before oxygen gets bonded to hemocyanin. Okay? Before oxygen gets bonded to hemocyanin, so we need to understand the structure. দেখো এই অ্যাক্টিভ সাইটে, at active site, ঠিক আছে, at active site, there are two copper 1 centers. There are two copper 1 centers bonded to histidyl nitrogen, বা আমরা more precisely বলতে পারি bonded to the imidazole nitrogen of histidine residues. ঠিক আছে? Bonded to কতগুলো imidazole nitrogen? 3 imidazole nitrogens. 3 imidazole nitrogens, এখানটায় লিখি better. So it is linked to 3 imidazole nitrogen of histidine residue in a distorted T-shaped environment. In a distorted T-shaped environment. তার মানে আমাদের ছবিটা কিরকম হবে? So if you want to look at the structure of the active site, so it's somewhat like this. দেখো আমরা প্রোটিন মইটিটাকে যদি এইভাবে দেখাই, suppose this is the protein moiety. এই ধরো প্রোটিন মইটিটা আছে like this. ঠিক আছে? So this is the protein moiety. So in fact this is a protein pocket, to be more precise. So this is a protein pocket where we see that এই যে দুখানা কপার সেন্টার আছে, ঠিক আছে, এবং এই যে দুটো কপার সেন্টার, দে আর লিঙ্কড টু হিস্টিডাইল বা ইমিডাজোল নাইট্রোজেন অফ হিস্টিডিন রেসিডিউ। এবং দেখো এখানে একটা জিনিস আমরা বলছি যে এইখানটায় আমরা মোটামুটি তো বলছি একটা distorted T-shaped environment. So it is somewhat like this. Uh, it's somewhat like this, and you'll find that the geometry around মানে এই হিস্টিডাইল যে দুটো কপারের এনভায়রনমেন্ট, if you look at the geometry, you'll find that this is practically এখানে staggered environmentটা is staggered লিখিয়ে দিচ্ছি আমি, so it's like this. So these are the imidazole nitrogens of histidine residue. So these are the imidazole nitrogens. So I'm just trying to draw them. So this is linked to the protein chain. This is how it is linked to the protein chain. In a similar way, same is the situation with this copper also. That means once again there are three imidazole nitrogens which are linked. So these are the histidines. So this is another histidine. So this is the structure of the active site. এবং এইখানে আমরা বলতে পারি যে দুটো ডিস্টর্টেড ট্রাইগোনাল বা টি শেপ এনভায়রনমেন্ট যেটা আছে, দিজ ইউনিটস, এইখানে এই দুটো ইউনিটস এর মধ্যে দ্য কপার কপার সেপারেশন, সো দিজ আর কপার ওয়ান, বুঝতে পারছো তো, কপার ওয়ান আছে in the in the in deoxyform, in deoxy-HMC, copper 1, copper 1 আগের কথা আমরা নিশ্চয়ই বলেছি, the metal center, this copper 1 in the deoxyform we can see copper 1 centers, copper 1, the geometry around copper 1 আমরা বলতে পারি, the geometry the geometry around copper 1 centers are staggered with respect to each other, are staggered with respect to each other, are staggered with respect to each other. এবং এইগুলোর মধ্যে ডিস্টেন্সটা ভ্যারি করে মোটামুটি দুটো কপার সেন্টারের মধ্যে। ইট হ্যাজ বিন অবজার্ভ দ্যাট the distance may vary from 3.7 plus minus zero point 0.4 to zero point 0.5 angstrom unit. So it varies from species to species. So this is the general structure of the active site. এবং এখানে দেখো this আমরা বলতে পারি যে এই এই যে এই this copper মানে rather this HMC hemocyanin is freely dissolved in the hemolymph, is freely dissolved in the hemolymph. তার মানে কোনো ব্লাড সেলের মধ্যে থাকছে না, unlike the case of hemoglobin, it is not present in any blood cell, it is actually freely dissolved in the hemolymph. Now in this deoxyform, the deoxyform is colorless, ঠিক আছে, so deoxyform is colorless because you can well understand it's a D10 system, and so the deoxyform has been found to be colorless because it's a D10 system. Now next question is, so this is the structure of the deoxyform, and since this is A D10 system, obviously it is diamagnetic. It is diamagnetic, colorless and diamagnetic. Now the question is, what happens upon oxygenation? Okay, so we shall discuss about how মানে অক্সিজেনেশন হওয়ার পরে নেক্সট কি হচ্ছে ঘটনা। তাহলে going to next page. Now see this copper 1 centers. There are two such copper 1 centers. Now in presence of dioxygen, now what happens in presence of dioxygen? These two copper centers, they lose electrons and they are converted to copper 2. And these two electrons lost, মানে একটা একটা করে electron lost হচ্ছে from each copper center. Now these two electrons lost from the copper centers, they are accepted by O2 and it is converted to peroxide. So this peroxide is formed, and this peroxide now gets linked. So this now gets linked to the two oxidized metal centers, in a bridging fashion, So what happens? It leads to the formation of a peroxo bridge. A peroxo bridge. So it leads to the formation of a peroxo বা peroxido যেরকম বলতে, ঠিক আছে, peroxo বা peroxido to be more precise, peroxido bridge. Now the formation of this peroxido bridge, there has been, see this copper 2 centers. Now the peroxide may get linked in two possible ways. One is, see this is the peroxide. You know that bond order is 1 for peroxide. There are two negative charges. And you see, this is how the peroxide can bridge the copper 2 centers. So this is what we say, mu hapto 2 is to hapto 2 mode of binding. Now both the oxygens, they are binding simultaneously to two copper centers. That's why hapto 2. So this is one mode of binding, and there is another mode of binding. Both these modes, they have been established. See, this is the second mode of binding, where the peroxide, each of the oxygen, they are getting linked to one of the copper centers. So these are the two major modes of bonding. So this is what we say, this is mu 1 2 peroxido, right? So mu 1 2 peroxido বা peroxido is more precise, mu 1 2 peroxido. তাহলে এখানে আমরা n, এখানে হিস্টিডিন দিতে পারি, n হিস্টিডিন আছে তিনটে, এখানেও তাই n histidine. There are three such n histidine. This is n histidine whole thrice. So there are two possible mode of linkages, and the formation of this peroxide, এইটা যে peroxide হচ্ছে, peroxide linkage, this has been verified by, first of all, তাহলে আমরা পরের পাতায় যাচ্ছি. So the formation of peroxide may be verified, has been verified, to be more precise, has been verified. Formation of the peroxide has been verified by, number one, from resonance Raman, resonance Raman spectroscopy, resonance Raman spectroscopy, where we get a stretch at around 744 centimeter inverse, which corresponds to formation of peroxide, which corresponds to formation of O2 2 minus. So first of all, um, this resonance Raman spectra এটা দিয়ে verify করা হচ্ছে. It can also be verified by extended X-ray absorption, fine structure, EXAFS. This is extended X-ray absorption, fine structure. So this is another method. ঠিক আছে? এবং এখানে এই exact studies থেকে it further proves that O2 2 minus binds to the two copper centers, in a symmetric fashion, in a symmetric fashion. Okay, so so this is what we this is the two spectral studies by which we can verify how the oxygen gets linked to the two copper center in the oxidized form of the protein. Now, the oxidized form of the protein, if you look at the color of the oxidized form of the protein, so the color, it is intense blue, color of oxy HNC. This is intense blue. And the high intensity of this color, a possible, some groups, they have suggested that this intense blue color is possibly due to ligand to metal charge transfer, from the uh, from the coordinated peroxide, coordinated peroxide to the metal centers, to the copper 2 centers. Now this copper 2, these are D9 system, copper 2 centers. তাহলে D9 সিস্টেমে কি তাহলে DD transition হবে না? Yes, there will be DD transitions, but the color of the DD transition will be masked by that of the charge transfer transition. DD transition তো হবেই, কিন্তু এখানে তুমি দেখবে এই মোটামুটি এই ল্যামডা ম্যাক্স, মানে যেখানে you'll find that তোমার the absorption মোটামুটি দেখা যাচ্ছে যে you get two bands, একটা দেখা যাচ্ছে 580 ন্যানোমিটারে পাওয়া যাচ্ছে and the other one at 340 nanometer. So you get two bands. এইটার বলছে দেখো epsilon value this is of the order of 10 to the power 3 and this is of the order of 10 to the power 4. ঠিক আছে? তো obviously তুমি বুঝতেই পারছো m inverse centimeter inverse. So the color is quite intense. Now regarding the magnetic properties. Okay, if you want to understand the magnetic properties, see among whichever structure you consider, তুমি দেখো ভালো করে, এইটা তুমি দেখো, এইখানে তুমি দেখছো এই copper 2 or the other structure. Now the oxyform, whichever structure you consider, it is diamagnetic. Okay, due to, so These are diamagnetic. So oxidized form is diamagnetic due to due to antiferromagnetic due to antiferromagnetic due to antiferromagnetic superexchange due to antiferromagnetic superexchange between the two paramagnetic copper centers copper two centers copper two centers via the orbitals of diamagnetic diamagnetic bridging perox, peroxide ligand বুঝতে পেরেছো? So it is diamagnetic due to antiferromagnetic superexchange. If you look at peroxide, if you just remember, if you look at oxygen, this was the pi star HOMO of oxygen, if you remember. Now, upon acceptance of two electrons, so it will be converted to what? This will be converted to O2 2 minus, and it will be diamagnetic because the two electron paramagnetism of oxygen is lost. Clear? So this is regarding the hemocyanin in your +3 level, BSc level.